In our last video, we talked about the quadratic algorithm. We discussed how the first thing we're going to do if we see a quadratic equation set equal to 0 is divide by the coefficient of x squared. That will give us something like this. And we'll assume we can factor it into x minus r times x minus s. And then what we know about r and s geometrically is that if this is set equal to 0, then those are our x-intercepts. So on the parabola, there would be these 2 points. We also know that r times s has to give us c. And we know that if you do r plus s, r plus s had to give us negative b. Then we divide both sides by -2. That gave us the average over here. And geometrically, that just means that you're halfway between those 2 points. We're now taking advantage of that, calling the distance c from the average out to the right or out to the left to get to those 2 solutions. So now this r times s equals c means since r is z plus the average and s is z minus the average, when you multiply them together, you get this difference of squares. And what pops out is the average squared minus z squared for this product r times s. We know that has to equal c. So now we're going to work out some examples using this. So let's make this our first example. Do a nice simple one. I want to do one that we already know the answer to, so you'll believe me that this process works well. We actually already know how to solve this pretty easily. We can just factor this left-hand side. It's x plus 2 times x plus 1. So x has to be -2 or -1. And so this algorithm that we're about to use is really not built for simple equations like this. It will work, but it will seem kind of bulky and meticulous. That's okay, I just want to show you that it works. Then when we get to the more complicated examples, that's when the value of this really comes out, this algorithm. All right, so the way it works, we've got to find the average. The average, remember, is just negative b divided by 2. So I've got -3 divided by 2. I need to square that because I've got average squared. And minus z squared equals c. C is 2 here. So now I just solve for z. I'll multiply this side out. -3/2 times -3/2 is positive 9/4. Remember, with fractions, you multiply straight across. So 3/2 times 3/2 is 3 times 3 over 2 times 2. And then let's subtract 2 from both sides, and let's add z squared to both sides. Now, I want to combine these fractions, so I'll rewrite 2 as 8/4. I know I need a common denominator of 4, so this is how I'm going to do it. I'll rewrite the 2 as 2/1, and then I'll multiply it by 4/4. Okay, and now I'll finish this up over here. I get 9/4 minus 8/4 equals z squared. 9/4 minus 8/4 is 1/4. So now I take the square root of both sides. On the right, I get z. On the left, I'm looking for a number so that when I multiply it by itself, I get 1/4. And 1/2 will do that. You can also get that number by taking the square root of the top divided by the square root of the bottom. And I'm missing something. I really need a plus or minus out in front. The reason is because whether you plug in the plus version or the minus version into here, it still satisfies that equation. So we found out what z is, and that tells us what our solutions are now. Our solutions are the average plus z and the average minus z. The average that we found was -3/2. So x is that average plus the z, or the average minus the z. And when we combine these, we get these two answers. So look, -3/2 plus 1/2 is -2/2, and -2/2 gives me this -1. -3/2 minus 1/2 is -4/2, which is the -2. So we did get the correct solutions here. They're the same as we got just by factoring the simple way. So remember, what I need is I need to find average squared minus z squared equals c, and just solve for z. The average we get by taking -b/2. So this is the same that we had for the first example. But this time c is equal to -2 instead of +2. So now let's simplify this and solve for z. Get 9/4 here. I'll add z squared to both sides, and I'll add 2 to both sides. Two I'm going to rewrite as 8/4 again. And now 9/4 plus 8/4 is 17/4. If you've forgotten about how to add fractions, as long as the denominator is the same, you can just add the two numerators, because it's like you're taking slices of pizza that are all the same size. So like 1/4 plus 2/4 would be 1/4 of a pizza plus 2/4 of a pizza. That gives you 3/4 of a pizza. So you just add the two numerators. Now to solve for z, take the square root of both sides. And when you take the square root of a fraction, you can take the square root of the top over the square root of the bottom. Square root of the bottom is just 2. So this is what z looks like. I really only need to use the positive version of this. But now, this tells me how to get my answers. The solution that we've been calling R, remember, was the average plus z. And we found the average to be -3/2. And then the other one, S, was the average minus z. So there it is. Pretty easy to do this once you're familiar with the algorithm. Again, go back to the other video to make sure, the previous video, to make sure that it makes sense why we're getting to here. We didn't need to use the quadratic formula. It should all make pretty good sense to you. And we were able to find a solution even though we couldn't factor in the old simple way. Third example I want to look at is one like this. I just wanted to give you an example of one where we've got a number out in front that still has relatively simple numbers. So remember, the first step in the algorithm, even though we didn't need to use it in the last two problems, is to get rid of this leading coefficient, the number in front of the x squared. So I'm going to divide everything by 3 here. Both sides of the equation, but 0 divided by 3 is still 0. So this is my B, and this is my C. And now what I need is average squared minus Z squared equals C. My average, remember, is negative B divided by 2. So I'm going to do negative B. And then instead of writing divided by 2, I'm going to multiply it by 1/2. Multiplying by 1/2 is the same as dividing by 2. And that's the easier way to do it when you're dividing a fraction. So average squared minus Z squared equals C. And now let's multiply this out. On top I get 4 times 1. On bottom I get 3 times 2. And I need to square this. So when I square this, the negative times negative goes to positive. And I want to think of the simplified version of this. 4 over 6 reduces to 2 over 3. 2 over 3 times itself gives me 4 over 9. I'm going to add Z squared to both sides and add 1/3 to both sides. I want to combine these two fractions. So I want to get a common denominator. I can do that if I multiply the top and the bottom here by 3. The reason I need to do the top also by 3 is because then I'm really just multiplying by 1, so it doesn't change the value of the fraction. So now I can add those two together. I get 5/9 equals Z squared. Take the square root of both sides. Get square root of 5 on top, 3 on bottom. And now I can write down the solutions here. So the solution R would be the average, which we calculated here inside the parentheses, negative 2/3. The average plus Z. And the solution that we call the S is the average minus Z. So those would be our two solutions. And the last example that I want to look at with you in this video, we're going to imagine throwing a rock straight up in the air, 32 feet per second. Let's say we start from a height of about 4 feet. If we graph the height versus the time, then of course as you let time go on, the height goes up, the rock goes up, and then it comes back down. So this is what that green curve represents. The actual equation that you get if you do that looks like this. This minus 16 is coming from a gravitational constant close to the Earth. 32 is coming from how fast you throw the rock. 4 is coming from the initial height from which you throw the rock. And then I want to ask the question, when, if ever, does the rock reach the height of 100 feet? So you can think about it and think about what your guess is. But I want to show you what the options are. We could have something like this. If this is 100 feet, then we could hit here and here. If we set the height equal to 100, then we should be able to find these two solutions. So if this is a height of 100, and we have this situation, we would find these two time values. And those two values of time would be the solutions to this equation. Another possibility is that the rock never reaches 100. So that would mean that 100 would be up here. So these are all question marks. We don't know yet. But if 100 is up here and the parabola never gets there, then there would be no solutions to this equation, or at least no real number solutions. But a third option is that it hits right at the peak. The peak would be 100. And if that were true, then when we factor out the equation, we would get the same solution in each part of the factoring. So we'd really only have one solution. Let's go ahead and try to solve this. Joy, is it still on?
Yeah.
Okay, thank you. Let's go ahead and try to solve this. Remember, for our algorithm, we always have everything moved over to one side, so one side is set equal to 0. So I'm going to go ahead and just add it, move all of this stuff over to the right side. So on the left, I'll have 0. On the right, I'll have positive 16t squared because I'm adding that to both sides. Minus 32t. And then when I subtract 4, I get a plus 96. And then remember, the first step of our algorithm is to divide by this leading coefficient in front of the squared term. So divide each term by 16. 32 over 16 is 2. 96 over 16 happens to be a nice number. It's 6. It's a nice whole number. It's worth asking ourselves if we can factor this out easily. So can I get two numbers that multiply to positive 6 and add to negative 2? 6 and 1 won't give me the right combination. 3 and 2 also won't give me the right combination. So I've got to go to our quadratic algorithm. So remember, for our quadratic algorithm, what we need to say is that the average squared minus z squared equals c. And again, we've already talked about the geometric significance of the average in z. Z is the distance from the average to your two solutions, out from the middle. Our average in this case is negative. It's negative b over 2. C in this case is 6. B is itself negative 2. So when I do minus negative 2, that gives me a positive 2. 2 divided by 2 is 1. 1 squared is 1. I'll go ahead and write it as 1 squared. So now I need to solve for z. I'll add z squared to both sides and subtract 6. 1 minus 6 is negative 5. So now I solve for z by taking the square root of both sides. And this is supposed to be my solution, but if you think about what a square root is, the square root of a number means I'm looking for a number so that when I multiply it by itself, I get back negative 5. The problem is that if you hand me a positive number and I square it, I get back a positive number. And if you hand me a negative number and I square it, I get back a positive number. So I can't get a negative by multiplying something by itself. So we'll say that this means there's no real solution. Later in the semester, we will talk about complex numbers where you define the square root of negative 1 to be the letter I, and it turns out to be super useful to allow that and to define the square root of negative 1 that way. If you've talked about complex numbers before, then you're at least a little familiar with what I'm talking about. If you haven't, that's okay. I'm going to hit this a little bit later in the semester. It won't be important for us here at the beginning, though. In this physical situation, what this means is that there's no time value, no real time value that makes this happen. So we're in this top case. The answer to this question is that the rock never reaches a height